All right, I want to make sure you guys are exposed to this absolute value type problem because it may be something you're going to see later on. If you remember a basic absolute value graph, okay, so let's say this is y equals absolute value of x, looks like a V, right? Now that V, depending on what else is in here, can slide side to side, it can slide up and down. So if you remember at all, from previous math classes, graph transformations, this -9, for example, means that you're moving it some direction this way. Okay, if it was +9, it would be some direction this way. Okay, so the key here is we want to know where is this touchdown point, where it touches the x-axis, right? Because we're going to have to add together the area over here, and we're going to have to add together the area over here, but we need to know where it touches the x-axis. Where's that cutoff point? Okay, so in order to do that, on every single absolute value problem, the first step you want to do is set it equal to 0, because that's going to tell you where your x value or where your y is, or basically where your zeros are. Okay, so if I solve, I would get x equals 3. Okay, what that tells me is if I were to redraw my V, at the number 3, I would have a touchdown point here. Okay, so it would look like this. Okay, so that's what that value tells you when you solve for x. Okay, the issue here is, so we're integrating from 0 to 5. Okay, so here's 0, and let's say 5 is over here somewhere. Okay, so we want to know what's the area under the curve right here, and what's the area under the curve right here. Okay, so it's going to take us adding together this piece and this piece. Okay, now in the past we did it geometrically. Now we're going to do it algebraically. Okay, all right. The issue here is you have two lines going on. Okay, when you see like this, the line that has a negative slope, that's sloped downwards, is the same thing as writing negative 3x minus 9. It's just taking your function 3x minus 9 and making it negative because your slope is negative. Okay, now at this point where your slope is positive, that function is going to stay as it is, 3x minus 9. Okay, so in absolute value, you're separating into the negative scenario and the positive scenario. Negative mean you're sloping down, positive mean you're sloping up, and you're touching down at 3. Okay, so these are like the first two steps of every absolute value integration. You've got a negative, you've got a positive, and you want to know where it touches down. Okay, so what I'm going to do here is just off to the side, if I distribute this negative sign, I can simplify this a little more. Off to the side, I'm going to write what our two functions are. We've got negative 3x plus 9. Okay, that belongs to this. And then we've got 3x minus 9. That belongs to this. Okay, so we want to find the area under the curve of this first piece, which is right here. Okay, so I'm going to go from 0 to 3. Okay, because at 3, it's no longer a negative slope. It becomes a positive slope, so I have to use my other equation. So I'm just going 0 to 3. Okay, 0 to 3 of negative 3x plus 9 dx. And I want to add to it. Now what am I looking at? I'm at 3. I want to go to 5. So it would be from 3 to 5. But now, since my slope is positive, I'm going uphill, I'm going to be using this function, 3x minus 9. Okay? And when I do that, I'm going to get the area under the first triangle, I'm going to get the area under the second triangle, and that's going to give me my answer. Okay, so let's integrate these separately. Okay, so this is going to become negative 3x squared over 2 plus 9x. Okay, and that's going to go from 0 to 3 plus, now we're going to go 3x squared over 2 minus 9x. Remember, I just took the integral here, from 3 to 5. Okay, so it's a lot of it's a lot of work. You can't lose track of where you're at here. So this first one, I'm going to plug in 3 and then I'll plug in 0. Okay, so this is going to be negative 3 times 3 to the second over 2 plus 9 times 3 minus, now I'm going to take 0, plug it in. So, but if I plug in 0 there, plug in 0 there, the whole thing is just going to be 0. Okay? Okay, then I have plus, now I need to do the same thing over here. I take 5, plug it in. I take 3, plug it in. Okay, so this is going to be 3 times 5 to the second over 2 minus 9 times 5 minus, now I'm going to take 3 and plug it in. So it'll be 3, I'll put this in its own parentheses, 3 times 3 to the second over 2 minus 9 times 3. Okay, now some of you might be sitting at home thinking, what in the world is he doing? Let me just backtrack. I took my integrals, okay, took 3, plugged it in wherever I see x, minus, take 0, plug it in wherever I see x. And I have my plus sign. Take 5, plug it in wherever I see x, minus, take 3, plug it in wherever I see x. Okay? Once I simplify all this and combine everything that I need to, that's going to give me the answer. Okay? So what's this going to be? This is going to be negative 27 over 2 plus, let's see, this is going to be 27 over 1. Okay, minus 0. I don't need the minus 0. Plus, okay, 5 squared is 25 times 3 is 75 over 2 minus 45 over 1. Okay, minus, and again, it's just a lot of calculations here. So 3 squared is 9 times 3 is 27 over 2 minus 27 over 1. Okay. Now, we got a lot of fractions here. Without taking too much time here, if I were to take the common denominator here, I would end up with a positive 27 over 2. Okay. Plus, now if I were to take the common denominator here, I would end up with negative 15 over 2 minus negative 27 over 2 if I took the common denominator between those two. And this would actually turn into a plus, which if I added those together, it would be a positive 12 over 2. Now when I add these together, I'd get 39 over 2. I know I blew through that last step kind of fast, only because I was taking common denominators. I encourage you guys to pause and go back and see if you can take these common denominators and get the same answer that I did. Okay, otherwise that's kind of the long version or long explanation of how to do these absolute value problems. There's going to be one like this on your assignment.